As we look at page 2, we're still dealing with volume, not necessarily using the formulas per se on volume. Um, but question number 3 says that the volume of a sphere. Okay, so I know that that means volume is 4/3 pi r cubed. Right, that is the equation for the volume of a sphere. And it tells me that that is equal to 600. So that means 600 equals 4/3 pi r cubed. So when I want to solve this, first thing I'll do is I'll get rid of the 4/3 by multiplying by the reciprocal, 3/4 on both sides. And that's because the 4 will cancel the 4 and the 3 will cancel the 3. So that means pi r cubed is equal to, so 600 divided by 4 is 150. And 150 times 3 is 450. 450. And then I have to get rid of pi. Divide both sides by pi. And I also have, that'll give me r cubed. It's like 143.24. Something like that. That's a rough estimate from a calculator. 450 divided by pi. And then to get r by itself, r is the cube root of 143.2. And it says round to the nearest whole unit. So that is just about 5 units. Right? If you're looking in your graphing calculator for the cube or root, hit the button that says math, M-A-T-H, and you'll see the cube root down there. I think it's number 4 on your list. All right, number 5 says determine what figure is formed from each cross-section or solid of revolution. On the test, you just have to name these. You do not have to draw these because I get it, I understand, I'm not very artistic. We can talk about what shape these are. So in this first figure, this cylinder being cut at an angle. If the cylinder is cut parallel to the ground, it would form a circle. But if the plane that cuts the cylinder is at an angle other than parallel to the ground, this thing will make an oval. All right, this circle will not be a circle, it will be an oval. All right, the second one here, this is a triangular prism that is being cut through one of the faces. Right, it is not being cut through the triangle, it's going through one of the faces. So this thing is going to make a triangle. That cross section would be a triangle. And it would be the same triangle that you're staring at there at the edge, that base. Number 5 gives us a two-dimensional figure that we're going to rotate around that axis. And what is going to happen here, and I'm going to just kind of superimpose this over the top. And let's flip this thing. Maybe. All right, so when I flip this, what would happen is as I start spinning this thing around and around and around and around, it's going to make this kind of shape where we have like 2 cones. And that thing would start spinning around in a circle, and it would make 2 cones that have been kind of joined at the base. And this last one, if I started to spin this thing around and around and around and around and around and around and around, what would eventually happen is this thing here would show up and it would be a cylinder. So it would be a cylinder, almost like a roll of toilet paper That you would kind of see as that thing would start spinning around and around and around and around. It would make a cylinder, but there would not be a hole in it. Remember, as we talked early on, if I wanted a hole in the middle of it, then this rectangle cannot touch the line. If that rectangle were away from the line a little bit, then it would leave a hole in the center of it like a roll of toilet paper. But this would make just one big cylinder. Number 6, there's a problem just like this one on there. I will give you either areas or volumes. So in this case, I give you 2 areas. And remember the things we're looking for. Scale factors, areas, and volumes. They tell me the areas are 36 over 25. So if I reduce 36 over 25, if I type it into my calculator and reduce that fraction, 36 over 25 reduces down to 4 over 25. So 4 over 25 is how that thing reduces. Well, if I'm going backwards from area, which I know area are units squared. So if I go back from area to scale factor, to get rid of the squares, I would square root, and the square root of 4 is 2, and the square root of 25 is 5. So that means the length of the sides of this figure would be in a 2 to 5 ratio. The areas would be in a 4 to 25 ratio. And volume, being a cubed, units cubed, the volume would be in a ratio of 2 cubed is 8, and 5 cubed is 125. So it would be in an 8 to 125 ratio. So let me move those over here now. So they're out of my way. And now what does this tell me? This tells me the volume. I have to find the volume of the small figure. Okay, so my 2 volumes, volume of small and the volume of the big one, they tell me is 750. I know that my ratio of volumes has to be in a ratio of 8 to 125. And now I can just cross multiply these things. So 125 times V is 125V. 8 times 750 is 6,000. Divide both sides by 125. And my volume has to be 48. And my label on volume, these are meters. So it's volume, so it's meters cubed. Now remember, if I give you 2 volumes, then what you would want to do is find the scale factor by doing the cube root of those 2 things to get the scale factor, and then square them to get areas. But I think, if I remember right, I think the test, I give you 2 areas again. So you're going to need to be able to square root them tomorrow. And the last question is finding population density. And population density is found by taking the population and dividing it by the area. So for this problem, it says determine the population density of Monaco if the population is 32,671 and the area is 1.2 square miles. And remember, we always want to round this to the nearest person. So if I do 32,671 divided by 1.2, I should get 27,226 people per square mile. Yeah, I know that seems like a lot as we were talking about the population densities of Ohio and the U.S. and Delaware and all those different things. Understand this, when you have an area that is so small and there are so many people in that small of an area, you're going to expect a really, really high population density. I mean, Monaco is 1.2 square miles as it is. So when I'm finding how many people per square mile, that's actually how many people would be out in 1 square mile. Well, we see that there are 32,000 671 people in just over a square mile, and actually 1.2 square miles. So I should expect that thing to be really, really high. So, I hope this helps. Good luck in your preparations. If you need to make a note card or a page or whatever you're going to need for tomorrow's test, go right ahead, and I'll see you guys tomorrow.